Good morning, everybody. Happy Wednesday, or as they affectionately refer to it as Hump Day. I was telling my brother this really is Hump Day. This is the day we have all our classes, so it is the day of the week that we have to truly get over. We're gonna get through it in grand style today. Alrighty. If you would go to Canvas and read over this paragraph about chromatography so that we know what chromatography is. I have a lab video for you to watch today. I guess if you were in the classroom, this would be something you would get to try for yourself, but since we're not, we have to watch it as a video. But it's a real simple task to do. So chromatography is one of the techniques that they use to examine organic materials. So while we're waiting for everybody to come in, if you would read over this section. We're kind of going to go look through the lab is one of those. Most of you have finished with your research, and did good research. A lot of, and I hope you read it because some of you all are just copying and pasting something you saw somewhere else, not giving credit. But I hope that you read the paragraph that you submitted because you do have to know what it is. You do have to know. I know you only had to pick one of the questions, but we're going to talk about all of the questions. Because technology is the way of the future. Again, while we're waiting, they posted the exam schedule, and science exams are the second week in December, and you'll probably just have a unit exam. We're not going to do a term exam. We'll finish this unit by the December 12th and test it on the 12th. So just a heads up for that. Okay. All right, so please read. We're still missing quite a few people. They're late. as you're reading these last two sections are give your attention to that. Make jot down if you take notes on things. You should take note of these. What do we use chromatography for in forensics? That's always your main question. There are two types of chromatography, and they're used for different things. So give your attention to those two areas as you read. I'm gonna give it another 5 minutes, and then I'm going to show the video. All right, we're reading in Canvas right now. Give it another minute. All right, and I'm going to stop sharing so I can do attendance. We should be reading chromatography in Canvas. Okay.
Aloha,
Okay.
my name is Dr. Kate Pro,
Whoops.
and I'm a
Hold
forensic.
on. All right. So this is a lab. It's a little mini lab, but it goes with chromatography. They're going to show you how they actually, she's going to do a simple demonstration of how they do chromatography in the lab. So please give it your attention.
Chemistry professor at Chaminade University of Honolulu. As a forensic chemistry professor, I teach classes in both forensic sciences and in our chemistry courses, and I also get to do research that helps me to find new information to help the field of forensic sciences. Forensic science is the study of science as it applies to the legal system. This basically means that we use forensic science in order to help solve mysteries. In forensic chemistry, we use the field of chemistry to better understand how a crime was committed. Today, we are going to use forensic science to investigate inks. Ink could be found at a crime scene on things like printed documents, but also on written notes. Today, we are going to see if we can use forensic chemistry to figure out which pen could have been used to write a note. The ink in a pen is made up of several different chemicals. Each of these chemicals has a slightly different color. And when we write with the pen or the marker, we actually see the combination of all those colors together. So each of these black markers is actually made up of more than one color. In this video, we are going to show you how to separate the different chemicals that are present in black ink using a technique known as chromatography. This is a piece of chromatography paper, and its purpose is to separate chemicals from one another. Along the bottom, we've taken a pencil and marked a line, and we've left 3 spaces where we're going to dot our samples. In this case, our samples are our 3 markers, so we're just going to put a spot of each marker in each of those spaces. Now we have all of our samples spotted along the bottom. Our chromatography paper sits inside of the beaker without touching the bottom. Pour a small amount of water into the bottom of the beaker. We only want it to fill the beaker so that it will be below the level of the spots. The paper is going to absorb some of the water when we place it into the beaker. The water will then start to move up the paper by capillary action. When the water reaches the marker that we've spotted, the marker ink dissolves in it. As the water continues up the paper, the mixture of chemicals in the ink will move differently with the water. Some chemicals like the water a lot more than others, so they move at different speeds. For example, if a chemical likes to be with the water a lot, or we say has a high affinity for the water, it will move further up the paper. If the chemical likes the water less, or has a lower affinity for the water, it will not move as far up the paper and stay near the bottom. So in this example, we can see that the yellow-orange color at the very bottom of the piece of paper actually doesn't really like to move with the water very much and sticks around near the bottom of the chromatography paper. However, the blues at the top of the paper like to move with the water quite a bit, and so they move upwards towards the top. Look at the finished product. Remember that these 3 black markers all looked nearly identical. Now we can see that they actually each have a different chemical profile. In a laboratory, we can use the chemical profile that's found in each of these inks after separating them out to figure out which pen, printer ink, marker, or other type of ink would have made a mark on a piece of paper. If you want to try this at home, you just need water-soluble markers that you'll use to spot onto a piece of paper towel. We've cut our paper towel to fit inside of our beaker, but you could use any type of drinking glass or a glass jar. We can see here that the results are not exactly the same. Paper towel has a looser weave between the fibers, and so things look a little bit more blurry. The chromatography paper is a special paper that's designed to be able to separate different chemicals from one another. So we have a more consistent structure on the paper, which gives us a little bit more definition between each of the spots. If you want to use what you've learned to solve an actual mystery, you can come up with a scenario with your friends or family members at home. Have one person choose a marker that nobody else knows the identity of, and have them write a spot on your paper towel. Then take all three of the markers and write them on alongside that unknown mystery spot. You should be able to match the mystery ink after you run the chromatography to a known correct pen. Hope you enjoyed using science to learn about how forensic chemistry can be used in an investigation. Crime laboratory scientists, for example at a police department or in the FBI, would use similar techniques to investigate evidence in a case involving ink. Museums also use similar techniques to look at different pieces of art and to see the composition of ink within those. Next time you use your markers to make art, you can think about chromatography.
Alrighty. Okay, so just wanted to share that with you. This is in your playlist if you want to check it out again. I know some of you, there's the reason why some of the folks are missing is because they're getting ready for that field trip today. So I'm going to let you finish up whatever you need to finish up. Like I said, most of you have done the assignment, and that's good. But if you haven't, use this time to finish up this assignment. We're not going to spend time in class on it on Friday. So please make sure that you get this done. We have an activity to do on Friday. Alrighty. And again, I know I only asked you to answer one question, but give the other questions a look. So in other words, you need to just have a general idea of what protein analysis is, what AI assisted spectral analysis is, and what is what do we mean by environmental DNA? Okay, so if you have some time, which you do, if you're already finished, another 10 minutes, um, please give those a good look. You don't have to write them up. Also, if you're missing anything, again, we're coming to the end of the semester. We only have 3 more weeks after this, and everything must be done. There's no going back. So if you're missing anything, now's the time to work on that. And again, you only had to answer one question, but you did have to include a picture. And the picture should go with, it should be a forensic type picture, one that actually illustrates the purpose of the tool in forensics. Remember, everything we do is directed at what does it have to do with forensic science?
Just any chat. It's clickable chat. Sure, you can tag me, ask questions, and even drop an emoji.
Is Serenity still here? Serenity, I don't have a test grade for you. Did you not take the test the other day? Do I need to give you a code so you can take this test? Let me know because I also have to open, I think it closed already. Mm, okay. All right, if you're in a good place to stop, time is up. I'll see you on Friday. Have a great rest of your day.